applications using linear inequality. It just means there's word problems, you guys. Now, here's the nice thing about the word problems is, as far back as I can remember, they've never asked us to actually write out an inequality for these, which does mean that you could solve them without inequalities if you chose. I am going to use inequalities just because we're in the module for it. But again, it's not required that you would have to. So, and that also means that we could interpret these as we go and solve these as well. So I'm going to be interpreting them as we go. Wyatt's goal is to find a job that provides an income of at least 42 grand a year. Emma's Furniture offers him a job paying a base salary of $20,000 a year, plus a commission of 6.5% of his sales. Determine what Wyatt's total sales will need to be for him to have a yearly income greater than or equal to $42,000. Okay. It's a good one. Now we're really comparing two things right here, right? We have I'm gonna call it Wyatt's goal, just goal, and we're gonna compare that to what he actually will make, right? So well, theoretically, what he will actually make. Maybe that's an oxymoron. But here's what we want. We want his goal of at least 42,000, right? So that means that if his goal was greater than how much he actually makes, nope, I take that back. His goal, he needs to actually make more than his goal. That's better. The goal is at least some amount. It seems like I'm doing this backwards. But if he made exactly the 42,000, he'd be fine, right? So the goal is also like if you said that's the minimum amount, instead of writing goal right there, where I did that'd be fine. But his goal is at least 42 grand, right? So I know the goal, I'll just replace it with 42 grand. But how much does he actually make? Well, he makes the base salary of $20,000 a year. And then in addition to that, he's also going to make 6.5% of his sales. Now, I don't want 6.5 there. I want 6.5%, which is actually 0.065. And I'm going to have to multiply that by the amount of sales that he makes, which I'll define it as X, okay? So again, whatever he actually ends up making needs to be bigger than his goal right there of 42,000. So again, it's 42,000 is less than or equal to 20,000 plus the 6.5% X. Now, if you have these flipped, it's fine. It just needs to be eating the 20,000 plus the 6.5% X. And yeah, now we got an inequality that we can solve very directly. So if I subtract 20,000, and again, there is an interpretation for this, which goes along with it. So we zeroed that out. That's good. We still got 6.5%, that should be 0, of his total sales, which is X. But when we subtract the 20,000 from the 42,000, then we get 22,000. This means that just from his commissions, he needs to make $22,000 if he's going to at least accomplish his goal. But then, well, yeah, we want to know how much he needs to make in commissions, right? So, yeah, we'll divide both sides by 6.5%, which is 0.065. And again, that's a positive, so it's not going to flip the inequality, which does happen even in these word problems from time to time. And I got to use the calculator. Here we go. First time for this one, 22,000 divided by 0.065. That was a big one. Maybe some of you guys expect that. I didn't expect to be that big. I get 338,000, and I'm going to round to the nearest penny. That seems appropriate. I guess it didn't really say, but I'm going to. $338,461.54. Now, it was 0.538, but the 8 rounds the 3 up. And yeah, don't forget to label this. Now, the interpretation, again, means that if Wyatt is to accomplish his goal, he could sell $338,461.54 in furniture, and then he would exactly meet his goal. Now, the reason why it's eating the X is because if he sold more than that, he would be fine with it. But yeah, that's determine what Wyatt's sales need to be You know what? I'm going to put this in a sentence. I don't think that the homework forced us to, or that if it did, it was already typed in. You just got to type the answer in. But again, we'll just, it's the interpretation of it. Wyatt needs to make sales, so he would have to sell. No, that's the wrong cell. Sell. Where's my dollar sign? There it is. Oh, that's the wrong one. 338,000. You want the comma? That's fine. $461.54. You know, I should say would have to sell. Would have to sell at least. That's what I should put. At least $338,461.54. So if we wanted to, we could write it differently, right? So we'll say Wyatt needs to sell. Well, it's. Oh yeah, here we go. We'll say $338,461.54 or more in furniture. I don't want to write that much though, so I'm going to keep it like that. So either one of these would work. And you bring up a good point on this, is if I wanted to rewrite it, we could say it's X. Now, it still needs to eat the X, right? And then it's still compared to the $338,461.54. So if it shows like this, in red what I got there, it's still the same. But yeah, it would read X is, but again, what is X? X is how much he needs to make in sales. So his sales need to be greater than or equal to $338,461.54. It means exactly the same thing, yep. Victoria needs to rent a car while on vacation. The rental company charges $25.65 plus 23 cents for each mile driven. If Victoria only has $62 to spend on the car rental, then she probably shouldn't do it. But we're going to go ahead with it anyways. What is the maximum number of miles she can drive? And we'll just round the answer to the nearest mile. But we got to be logical about this, okay? She's only got $62 to spend. That's the maximum amount that she has, no more. So we'll have to keep that in mind as we solve this, all right? So I'm going to write the inequality for this. Let's see, what are the two things we're comparing on this? It says we're comparing how much money she actually has and how much she's going to be spending, right? So we'll write it like this. We're going to do spending money, and we're going to compare this with money she has. Oh, that seems to work. Now, she could spend exactly equal to the amount of money she has, but she definitely can't spend more, right? So however much money she spends needs to be less than it or equal to however much money she has. All right. Now, how much money is she spending? Well, she's going to spend the $25.65 first of all. That's how much it just costs to rent it altogether. But then another 23 cents for each mile driven. So it's 23 cents. And please don't get this mixed up, you guys. It's common in the past when we saw problems like this on a test, where students would, instead of putting 0.23, they'd put 23 on there, which is different, okay? That'd be $23, and that's very, very different. Well, how much money does she have? Well, she's got $62. So again, we'll interpret this as we go, but the 23 cents is per mile, so we'd also have to multiply that. I should have done that before. Got to multiply the 23 cents by each number of miles that she drives. Yeah, we'll keep it at that for now. So this is our inequality. We can solve it. It's pretty good. So zero out that $25.65 from both sides, which also, again, and this would be the interpretation of it, this is going to tell us how much of her money she has to spend on the mileage. So that's going to zero that out. I'll drop the 23 cents per mile. Doesn't change the inequality, so I'll go to the calculator for this one. 62 minus 25.65. So yeah, she would have had left over $36.35 to spend on mileage. So the maximum number of miles she can drive, we'll just divide both sides by the 23 cents. And again, that's not going to flip the inequality. So X, that's the number of miles she can drive, needs to be less than, but it could be equal to, what is that? Divide by 0.23 in the calculator, 158 point, I'll say 0.04 miles. Now, I did say to round to the nearest mile, though, so even if you said, well, I could round this up to, like if it was 158.57, right? You'd say, I could round that up to 159. The problem with that is that since this is kind of a real-life situation, you'd say, well, that would put her beyond the $62 limit as well. So wherever you are in the 158 miles, you would need to round that down in either case, right? Because if we were to substitute 159 miles in for this original inequality, it would have given us a false statement. So just rounding this one, X, the number of miles she can drive, needs to be less than or equal to 158 miles. Then, I mean, it won't be equal to, but it will be at least less than the $62 that she had. So yeah, since it's a word problem, we'll write this as a sentence, because everyone loves writing sentences, you know, in a math class. So, Victoria, right? Victoria can drive at most 158 miles. And yeah, you could say, let's see, she can drive 158 miles or less, or I don't know. I'm struggling to find ways to restate that, but I think you guys get the picture. A student has scores of 65, 72, and 95 on his first 3 tests. He needs an average of at least 80 to earn a grade of B in the class. What is the minimum score that the student needs on the 4th test to ensure B? Now this is an average, you guys. Now I don't always show averages with fractions, but you can, right? And the average, whatever it is going to be equal to, it's going to equal the sum, right? We're going to be adding numbers together, and then we divide it by however many numbers there are. That would equal the sum. Now the sum in this case needs to be at least 80. So that means that when we compare the average, which is the left side, to 80, which would be the actual average, to 80, which is this hypothetical right here. It needs to be greater than or equal to the 80, right? Like this student is okay if they get exactly 80, but if they could get more, they'd be really happy about it. So the 3 test scores that we have up here are 65, 72, and 95. Now the 4th test score, we don't know what it is. So that's going to have to be our unknown, our variable in this case. And now we're going to divide it, because that's the average, by all 4 test scores. 4 test scores. So we'll divide it by 4 right there. So this brings up a different type of inequality. I don't know that we've seen one exactly like this before in the last section or this one. But it brings up a situation where we got to get rid of that divide by 4. I want to get rid of it right now. I don't want to separate those into 4 separate fractions. So I'm going to get rid of the 4 right now by multiplying both sides by 4. Which makes that a phantom 1. All right, so I still got those 4 test scores, 65, 72, 95, and X. I need the sum of them, so we're going to add those together. And it needs to be greater than or equal to what would be the total value, which would give us the average of 80, of 320. All right, so yeah, we've defined it, and we have a pretty nice inequality that we can solve just like we would a regular equation. And I'm going to combine all my like terms, all 3 of these values right there. So I'll go to my calculator. What the heck? There we go. Oh, that's the wrong button. 65 plus 72 plus 95, right? 108. So right now the student, that seems off. Oh, it's a Yeah, that. Oh, see, I even typed in the wrong one again. 65 plus 72 plus 95. There we go. 232. See, that seems a lot more reasonable with those three test scores. 232. So right now, the student has scored 232 points on the first three tests. And yeah, some of you guys are like, I already know what he would need on that fourth test, but I'm going to continue on, right? We need to add that fourth test score. It needs to be greater than or equal to 320. And sure enough, that's a 0. Sure enough, to solve this thing, all we need to do now is subtract that 232 from both sides of the inequality. Now this student is cutting it close, and you could say, well, logically, would the student make it? It's up to you, you know. Oh, I should do 320 minus 2. Oh, dang it, I did it again. 232. 88. Oh, I thought it was even more than that. So 88, is this student likely to get an 88? Possibly. They scored a 95 on a previous test. So yeah, I'd say, you know, I'd give them a good sporting chance on that 88, especially if they, you know, studied hard and worked hard and really felt like they understood the material. Okay, but this is the minimum score, so I'll put it in a sentence as well. I know you guys wanted it in a sentence, so here we go. The student must, yeah. Let's see. Yeah, I got you. So I only subtracted the 232 from both sides. That's subtraction. Now we only flip that inequality if we've used multiplication or division with negatives. But where it's where it's straight subtraction on that, bam, it's good to go. Maggie is trying to qualify for the local bowling championship. To qualify, a person must bowl 5 games and have a combined average score of at least 175. You guys see that average thing right there? In the first 4 games, Maggie scores 171, 179, 160, and 186. What is the minimum score that Maggie must bowl in her 5th game to qualify for the local bowling championship? And maybe we can do some evaluation on if Maggie is actually likely to obtain that score. But well, let's figure out what score she needs first. So again, it is an average. And the actual average needs to be greater than the average that she's shooting, or equal to, of course, than the average she's shooting for, which is 175 right now, right there, right? And we're looking at 5 values on this one, even though they only gave us 4 because she's going to bowl that 5th game. So here's our 5 blank spaces. And just the 4 first games that she bowled, she got a 171. All of these would destroy me, you know what I'm saying? I don't know about you guys. But yeah, Maggie's pretty good. And then, of course, that 5th game, which, again, I'm using X because she hasn't actually bowled it yet. And the X value will tell us what value she needs to bowl at least. So we're going to divide this by the 5 scores right there. And this sets up the inequality for us. But again, it's going to work the same way as that last one did. I got to get rid of that 5 denominator by, I'm just going to multiply both sides by 5. Some of you guys would be like, that means we're going to find common denominators, right? And yes, that's true. It would do the exact same thing. I'm just kind of skipping a step on this. So yeah, I'm not familiar with 175 times 5. So here we go. 875. That's how many points she needs from all 5 games at least. Right, so she's still got the 171. She's got the 179er, 160. 186, and then that final 5th score right there. We're going to add all 5 of them together. But yeah, we got this like terms, all these constants that we can combine together. So 171 plus 179 plus 160. I know some of you guys can do that faster than in your head than I'm doing on the calculator, but that's okay. Calculators are good. 696. But again, we got that 5th score right there. And yeah, should be at least 875 points. So finally, we'll just subtract 696 from both sides here. Just need a little bit more space. Subtract 696. And that tells us the minimum score that she needs. And again, we're only using subtraction here, so it's not going to flip the inequality. Minus 875, and that's negative, but it wouldn't matter. It's still positive in the work that I got. So 179, that's what she has to bowl. And she's accomplished that before, and she's even got a better score than it before. So I would say that Maggie has a pretty good chance of accomplishing this. But again, I'm going to put it in a sentence just so it makes a little bit more sense. Maggie must score 179 on the 5th game or more. And, you know, if you said 179 or more on the 5th game, maybe in terms of English writing, that would make more sense. But I'm a math guy, and I feel like I can use that as an excuse right now.